Okay, time for a grams to moles problem. Given the balanced equation with phosphoric acid and sodium hydroxide combining to react and yield sodium phosphate and water, it says how many moles of water are produced when 28 grams of phosphoric acid react completely with sodium hydroxide. Now I read all that rather quickly. Let's go over a couple of key points. First, you're dealing with a balanced equation. And you should always be dealing with a balanced equation for these kinds of stoichiometry problems. If you're in a more advanced class, like for example, honors or AP level chemistry, the teacher may not give you the equation balanced. But here I'm making it very clear that I am giving you a balanced equation, because what I really want to focus on is showing you how to go from grams of A to moles of B. Okay, so let's take apart the problem and decode it a bit. So what they want to know is how many moles of water. Okay, this is what they're looking for. And your given information is 28 grams of phosphoric acid. And that's this substance right here. So in this case, the substance that you're given, which is here, that's substance A. The substance you're looking for is substance B. So for the purposes of this equation, you're going to focus on this compound and this compound. Okay? We don't have to worry about anything else with the other two. Okay, so a couple of things. Actually, before I begin, I was going to jump into the problem, but let me give you the roadmap for how we're going to do this. First, you have to go from grams of A into moles of A. All right. Now, once you've got moles of A, you can convert that into moles of substance B, and then you're done. So we're going to need two conversion factors to make this transition and this transition. All right, now we're ready to begin. So I'm going to start with the blue pen here. And, okay, so I think we're good. So we've got grams to start with. So they gave us 28 grams of H3PO4. Now, if I want to go from grams into moles, I need to know something called the formula weight, or the gram formula weight, or the gram formula mass, as it is sometimes called. And that means we're going to need a periodic table, because that's where all the masses are. So we have to take a look at the formula, and we have to do like a separate little mini calculation to figure out the mass of phosphoric acid. So here's hydrogen, and the mass of hydrogen is 1.01. We have 3 of them, so we're going to need to add 3 of those together. Next we have phosphorus. Now, both phosphorus and oxygen are found in the non-metal section over here. Phosphorus has a mass of 30.97, and oxygen has a mass of 16. So 30.97, and then we have 16, but there are 4 of them because it's O4. So 16 times 4, we can do that on the calculator real quick, is 64. Okay, so I'm going to add all of these up. And now I know that the molar mass is 98 grams per mole. And this is for my, again, phosphoric acid. So now that I know that the molar mass is 98 grams per mole, then what I'm going to do is I'm going to put that 98 grams down here. And I'm going to put 1 mole of phosphoric acid up here. Now you may wonder, why didn't you put the 98 up top? Why did you put the 98 in the bottom? Okay, so let's think about what we have. We were given 28 grams of this phosphoric acid. When I set up my problem using dimensional analysis, I need to make sure that I cancel the grams of phosphoric acid with the grams of phosphoric acid in my conversion factor. Excuse me. So, just like when you're driving a car, let's say we were driving super fast and hopefully on a racetrack going 98 miles per hour. Well, that means that we're doing 98 miles every 1 hour. So just like we would have miles per 1 hour, this is 98 grams per 1 mole. And that's why I wrote the 1 mole in the top, because this is 98 grams per 1 mole. Okay? So that allows us to go from grams to moles of phosphoric acid. Okay, next step, we got to go from moles of phosphoric acid, which is substance A, into moles of water, which is substance B. Okay, so how do I go from moles of phosphoric acid to moles of water? Well, we know from the previous problem that we need to cancel things by writing the next unit in the bottom. Whoop. Let's just pretend that was a fancy P. Okay, and we're going to put moles of water in the top. And so how are we going to understand the ratio between these two? Well, the relationship or the ratio is 1 to 3. Now you start to see why we need a balanced chemical equation, because that's what is going to tell us the molar ratio. The coefficient here is understood as 1 when there's no number present, and here we have a 3. So that tells us the ratio is 1 to 3. Now remember, the 3 has to be with the water. So when I use that information, I put the 3 with the water, and I put the 1 with the phosphoric acid. Okay? Because my goal is to make sure that moles of phosphoric acid cancels with moles of phosphoric acid, leaving me with moles of water. All right. So now that we have the problem set up, and we're going to end on the unit that we desire, we can now solve the problem. So I'm going to multiply the tops and divide the bottoms. So 28 times 1 times 3, that's multiplying the top numbers. Then divide by 98 and divide by 1, and that's by dividing by the bottom numbers, giving us a final answer of 0.86 moles of water. Now it's not a lot, but it doesn't really matter. Okay? The most important thing is that your units canceled and you put the correct numbers with the correct units. And that's our answer, 0.86 moles of water. Now what I would recommend is that you download the free worksheet and then see if you can solve this problem completely on your own. If you need a clue, you can always play the video again and then hit the pause button after you get enough information for your clue and see if you can continue solving the problem from that point forward. Okay, remember, all grams problems, anything that deals with grams, got to have a periodic table. Make sure you got it handy, and that's it.